scalar product of the two vectors, which is f and v. Now, to find the scalar product, and let's sit down a little bit and just think about it, because they specifically word this question so that it's confusing. Okay, like why in the world are we taking theta from two different from two different axes? Like that doesn't even make sense, right? Like why are we taking it from the x and then we're taking it from the y? There's no order to this, and they do this to confuse us. So let's sit down and think. To get the cross product, we're doing some vector, which in this case it would be f and v, right? We're gonna do f times v cos theta. Now you may sit there and be like, which theta? The answer is none of them, because none of them are the correct theta that we need. What we need is actually not, we don't need this, we don't need this, we don't need this, we don't need this. Awesome. Last time my laser pointer didn't go away, but now it did. Okay. We don't need any of those. What we need is the angle in between f and v. Okay. Let's do that. How do we find it? This is just, we sit there and we think through simple math, okay? We need to find this quadrant alone, right? We need to be able to get this quadrant alone. Why am I saying that? I'm saying that because we know that this right here, maybe I should have left that square. We know that this quadrant over here, I'm going to use a highlighter, this quadrant all the way down here, this one, right? Each quadrant has a measurement of 90 degrees. If we can find the measurement of this angle and the measurement of this angle, we add them together and then we subtract them from 90, then we can find this angle. Wow, mind-blowing! So how do we get there? Okay, I'm going to use a lot of symbols because I'm not actually going to solve it for you and I'm not going to give you guys the answers, but I'm going to show you guys the method, and that way we know exactly how to solve it. And we need to also make sure that we understand it logically. So we're going to call this theta 1n, n for nu, okay? Theta 1n is going to equal to theta 1 minus 90. Why, you might be asking? Well, let's get rid of this part, okay? This part right here, we don't need it. We don't need that. We're going to do the same thing for theta 2n, which is going to equal to theta 2 minus 90, because we don't need this part. And now what we're left with, theta 1n and theta 2n, are going to be this part and this part. Maybe red isn't the best color to showcase this. I'm going to go for purple. It's going to be this part and this part, okay? If we add theta 1n, that looked terrible, plus theta 2n, then we get some phi, okay? I'm using different symbols. Bear with me. We get that phi. Let's subtract that phi from 90. Why? Why am I subtracting that phi from 90? Let me show you, okay? I'm going to zoom in just on this quadrant. Just on this quadrant. Okay? If I were to redraw this, just that quadrant, remember, that's all we're doing, okay? If I were to redraw this quadrant, I know it's not perfect, don't judge, okay? With the two vectors coming down like this. And we know this as theta 1n, and we know this as theta 2n. Isn't it right to assume that this altogether, the equation for this, would be the total theta, or theta t is equal to theta 1n plus theta 2n plus some just theta, which is going to be this angle right here? Yeah, it would. So if we were to put brackets like this, okay, and we were to rearrange this equation, let me lasso all that. Let me get it somewhere else, okay? Because we need to move. Okay, there we go. Okay, it would be safe to assume, it would actually be accurate to assume even, that theta t minus theta 1n plus theta 2n is equal to theta, right? And this is the theta that we ultimately need. So instead of saying theta 1n and theta 2n, we just put it all into one. So this is the theta t minus phi, which is going to equal to theta. Guys, ignore the background. This is going to be 90 minus phi is going to give us that theta. We take that theta, and what do we do with that theta? We plug it in, okay? And then that will give us our final value. Remember, your final value, because we didn't convert this V is going to equal to some value, which I'm going to call, why is this not writing? X Newton times centimeters per second. Okay, we're taking this and multiplying it by this. Remember that. So when you guys go to write your answer, don't put it in meters per second. Don't. Unless if you convert, then you can put it in meters per second. That's up to you. I digress. This is how you solve it, and this is how this comes to be. It's actually quite simple.